All right, let's look at how to draw stuff on the oscilloscope screen. Here I got two cables that are both connected to this power supply using this T, and let's turn on the power. So I got 2 volt on both channels, channel 1 and channel 2, and you can see the voltage over time. It's constant voltage. So because this is on YT mode, but we can change the YT mode to XY mode, where it will plot a point at X voltage comma Y voltage. And the way you do it is you go to display, you change YT into XY. Now because both of our voltages were 2 volt, so we have a point at 2 comma 2. Let's change the voltage. I can change the voltage by going here, and when I change the voltage, you can see that point will move towards 0 because I'm decreasing the voltage. You can see it is changing. So this is basically plotting a point at a voltage at X channel, comma voltage at Y channel. Okay, so this is the basic, but we can have more fun if we have a function generator instead of a power supply. So let's hook that up. All right, now I got a function generator hooked up here. I got channel 1 connected to channel 1 of the function generator, channel 2 connected to the channel 2 of the function generator. And let's go back to YT mode and let's look at both of those signals. So to go to YT mode, I'll have to go to display, change the format to YT, and it's a 0 volt because I haven't enabled my signal. So for both first channel, I'm using 1 kilohertz sine wave, and for the second channel, I'm using 1 kilohertz sine wave as well. Let's enable channel 1, and you can see the sine wave is already there. Let's change my seconds per division so that I can see more of my wave. There we go. And let's turn on the channel 2, and channel 2 is there as well. But when we look at them, you can see they're offset, although the phase is the same. And that's because because I turned on this one first and this one second, so there was some phase offset. But you can align them by using this align phase button. So when I click this, both of these signals should be overlapping. Okay, so I got a sine theta in x equals sine t, and y is sine t as well. So x and y are equal, so that means it'll should draw a line when I go to XY mode. Let's do that. Let's go to display, change to XY, and you can see it will draw a line. But if we want to draw a circle, we can parameterize x as sine t and y as cosine t, and we can do that by just changing the phase angle. So if I change my phase angle to 90 degree, it's to turn sine into cosine. So if I change this to 90 degree, and that should draw a circle. That's because that's the parametric equation of the circle. But we can also draw other stuff. For example, we can put a square wave on the first channel. Let's put a square wave on both channels. Then I guess our x and y will be the same. Either there will be same positive value. For example, for our case, we have amplitude of 5. So there will either be 5, 5 or minus 5, minus 5, right? If they're in phase. So it's a draw 2 points. It's drawing 4 points. I think that's because it's not, they're not synced. Let's align phases. Oh, I see. That's because we got a phase of 90 degree for our second channel. Let's change the phase to 0 again. So let's change the phase to 0 degree. Then it should be 2 points, because if two square waves are in phase, they either are going to be, they're always going to be equal in magnitude, but they could be plus amplitude or minus amplitude. So we see 2 points there. All right, so we can also use any kind of signal here on both channel, and you can see what it will draw. If I put noise in both channel, this is what it draws. You can use this to plot IV curve of a diode or a transistor. You can put current in one of the channel and voltage in other, and you can just get the IV curve just on the screen using that. And you can also play video games by just supplying this signal using some microcontroller. You can display anything you want, and this is a nice vector display. All right, that's it. Bye-bye.